Refrigeration is often seen as a universally beneficial way to preserve food. However, not all foods benefit from being stored in a cold environment. In fact, refrigeration can disrupt the natural enzymatic activity and nutrient profiles of several types of food, especially fresh produce. This interference doesn't just impact taste and texture, it can also compromise the health benefits we expect from these foods. Understanding how refrigeration affects enzymatic function and nutrient content is essential, particularly for those seeking to maintain a nutrient-dense diet for longevity, hormonal balance, and cellular health. Enzymes are biological catalysts found in nearly all raw and living foods. They assist with digestion and help the body break down and absorb nutrients. Many fruits and vegetables continue their enzymatic activity even after harvest, especially during the ripening process. Refrigerating these foods can slow or completely stop this enzymatic activity, altering their nutritional makeup and sometimes rendering them less beneficial. For instance, cold temperatures suppress the enzymes that contribute to the ripening of bananas, tomatoes, and avocados. This results in textural changes, flavor loss, and even a reduction in antioxidant levels. Tomatoes, for example, are highly sensitive to cold. When stored below 50 DEGF, 10 DEGC, their membranes begin to break down. The result is a mealy texture and a significant drop in the concentration of lycopene, a potent antioxidant linked to reduced inflammation and cancer prevention. Lycopene formation is part of the ripening process, and this process is severely hindered in a cold environment. In this way, refrigeration actually depletes the very nutrient people often eat tomatoes for in the first place. Bananas undergo a similar transformation. Refrigeration causes their peel to turn black while the inner fruit stops ripening. What many people don't realize is that this also impacts the resistant starch content of bananas. Resistant starch is a type of carbohydrate that behaves more like fiber than sugar and has been shown to support gut health, insulin sensitivity, and satiety. When bananas are refrigerated prematurely, the resistant starches degrade more quickly into simple sugars, leading to higher glycemic effects upon consumption. This is especially problematic for individuals with insulin resistance or metabolic concerns. Even leafy greens and herbs, though typically kept in the fridge, can suffer nutritionally if stored improperly. These delicate foods are high in water content and vitamins like C and B complex, which are extremely sensitive to cold-induced oxidation. While refrigeration can slow microbial spoilage, it can also accelerate vitamin degradation if there is too much humidity or exposure to ethylene gas from other produce. This is why leafy greens often appear wilted, slimy, or discolored after a few days in the fridge. The nutritional profile, particularly folate and vitamin C levels, diminishes over time in such conditions. Onions and garlic provide another example. These vegetables contain sulfur-based compounds that offer potent antimicrobial and cardiovascular benefits. When refrigerated, these compounds can break down prematurely due to condensation and enzymatic interruption. The cold and moist environment encourages mold and bacterial growth instead of preserving the integrity of their healing properties. In this case, room temperature storage in a dry, ventilated space is far more effective at preserving both freshness and nutrient value. The impact of refrigeration extends beyond micronutrient loss. In fermented foods like kimchi and sauerkraut, refrigeration is necessary after opening to prevent over-fermentation and spoilage. However, for unfermented whole foods, refrigeration can create chemical imbalances. Many phytonutrients, plant-based chemicals that serve protective roles in the human body, are temperature sensitive. Flavonoids, polyphenols, and enzymes found in fruits like peaches, melons, and citrus can deteriorate more rapidly under cold stress. This means that even though the food may look intact, the bioavailability of its nutrients is compromised. In addition, refrigeration can interrupt the natural microbial colonies found on fresh produce, which may have a subtle but important effect on the gut microbiome. These naturally occurring microbes found on the skins of apples, berries, and leafy greens can serve as low-level probiotics when consumed raw. By refrigerating these foods immediately or for too long, we alter the microbial composition, sometimes reducing the diversity and vitality of these beneficial organisms. This matters for individuals looking to support immune function, reduce inflammation, or improve mood and cognition through diet. For individuals eating to optimize their mitochondrial function, insulin regulation, and hormone balance, even small disruptions in enzyme and nutrient activity can have a cumulative effect. If the foods you're consuming are less bioavailable due to improper storage, you're not receiving the metabolic advantages you believe you are. Over time, this can contribute to nutrient deficiencies, hormonal imbalances, and lowered resilience to stress or inflammation. Resistant starches and antioxidants play a crucial role in maintaining metabolic health, regulating blood sugar, and supporting cellular repair. However, what many people don't realize is that the way we store food, particularly at cold temperatures, can dramatically alter these compounds, often reducing their effectiveness. While refrigeration may preserve freshness and prevent microbial growth, it also initiates changes at the molecular level that affect the nutritional value of food. Understanding how cold temperatures affect resistant starches and antioxidants is essential for those aiming to optimize gut health, insulin sensitivity, and overall well-being. Resistant starch is a type of carbohydrate that resists digestion in the small intestine. Instead of being broken down into glucose like other starches, it passes through to the colon where it acts as a prebiotic, feeding beneficial gut bacteria. This fermentation process produces short-chain fatty acids, like butyrate, which improve colon health, reduce inflammation, and enhance insulin sensitivity. Foods rich in resistant starch include bananas, potatoes, legumes, and certain whole grains. However, the content and quality of resistant starch can shift dramatically depending on how the food is prepared and stored, especially when cold temperatures are involved. Take bananas, for instance. Green, unripe bananas are high in resistant starch. As they ripen, this starch converts into sugar, reducing its metabolic benefit. When bananas are refrigerated before fully ripening, the enzymatic activity that converts starch to sugar slows down, which might sound beneficial, but this cold exposure can also damage the fruit's cellular structure and diminish the effectiveness of the resistant starch already present. Moreover, refrigeration can lead to the breakdown of cell membranes, making the fruit mushy and more prone to oxidation, especially in the case of bananas that are later brought back to room temperature. Potatoes are another staple where resistant starch plays a role. Cooked and then cooled potatoes form a specific type of resistant starch called RS3, or retrograded starch, which develops as the gelatinized starch chains realign during cooling. This can make cold potatoes more metabolically friendly than freshly cooked ones. However, the cooling process must be gradual and not overly extended in extreme cold, such as deep refrigeration or freeze. When exposed to prolonged cold, the structural integrity of the starches can degrade, especially when reheated improperly. This results in a loss of the RS3 formation, diminishing its prebiotic effect. In addition to resistant starch, cold temperatures also affect antioxidants, compounds that neutralize free radicals and reduce oxidative stress. Antioxidants like vitamin C, polyphenols, and flavonoids are highly sensitive to environmental conditions, particularly temperature. When foods high in antioxidants are stored at low temperatures, especially if combined with moisture or light exposure, degradation can occur. This means that even though a food item may appear visually intact, its antioxidant potency might be significantly reduced. For example, tomatoes and berries are known for their antioxidant richness. Tomatoes are high in lycopene, a powerful compound linked to heart and prostate health. Cold temperatures inhibit lycopene production in post-harvest tomatoes and can cause cellular damage that interferes with the release of this nutrient during digestion. This is particularly important for individuals relying on antioxidant-rich foods to reduce inflammation and support recovery from oxidative stress associated with aging or chronic illness. Berries, such as blueberries, strawberries, and raspberries, are especially vulnerable to cold damage. Their skin contains anthocyanins and other polyphenols that are responsible for much of their health benefit. When stored at very low temperatures or frozen without protection from air and moisture, these compounds begin to degrade. Enzymatic reactions slow in cold environments, but oxidative enzymes can still react if the fruit's cells are damaged. As a result, antioxidant capacity diminishes and the fruit loses its ability to provide the protective effects originally intended. Even citrus fruits, which contain high levels of vitamin C, experience degradation under prolonged refrigeration. Vitamin C is water soluble and heat and cold sensitive. It can oxidize quickly when the fruit's membranes are disturbed, such as through refrigeration-induced dehydration. This means the longer these fruits stay in the fridge, the less effective they become at delivering their immune-boosting and collagen-supporting benefits. The disruption of these nutrient profiles through cold exposure is further exacerbated by modern refrigeration practices. Many refrigerators cycle through humidity and temperature fluctuations due to door openings and automatic defrosting. These small, repeated changes increase the likelihood of condensation forming on food surfaces, accelerating nutrient degradation. Additionally, ethylene gas released by some fruits during ripening can hasten the breakdown of nearby produce, especially in a confined, cold environment. People striving for metabolic health, muscle recovery, or anti-aging benefits through diet must consider not just what they eat, but how it's stored. Resistant starches and antioxidants are not static. They respond dynamically to preparation and storage methods. To preserve their benefits, careful control over temperature, timing, and humidity is necessary. Cold can be helpful when applied correctly, such as forming RS3 through a cook and cool method, but indiscriminate refrigeration may quietly erode the very nutrients the body relies on for healing and energy restoration. Moisture and condensation are often overlooked factors when it comes to food storage, yet they play a critical role in promoting mold growth and bacterial overgrowth in our kitchens and refrigerators. These seemingly small environmental conditions can quickly create a perfect storm for microbial activity, particularly when food is improperly stored or when refrigeration conditions fluctuate. For anyone trying to protect their health, immune system, and digestive tract, understanding how moisture influences spoilage and contamination is vital. When food is placed in a refrigerator, it is naturally exposed to varying degrees of humidity. This happens especially during door openings or temperature shifts within the unit. As warm, humid air enters the cold environment, it condenses on food surfaces, packaging, and even internal refrigerator walls. This accumulation of moisture, particularly when it pools on fruit skins, vegetable leaves, or inside containers, provides a nutrient-rich environment where mold and bacteria can thrive. The cold temperature slows some forms of bacterial growth, but it does not eliminate it. Certain bacteria and fungi are cyclotrophic, meaning they continue to multiply at low temperatures. Fresh produce is particularly susceptible to moisture spoilage. Leafy greens, berries, and mushrooms are notorious for becoming slimy or moldy when stored improperly. These items have a high water content to begin with, and when extra moisture from condensation settles on them, it accelerates cell breakdown and microbial colonization. Berries stored in sealed containers without proper airflow can go bad within just a few days, even if they were fresh when purchased. Visible mold is only the surface layer. Below, invisible bacterial communities are also thriving. Moisture doesn't just impact whole fruits and vegetables. Cooked food leftovers, dairy products, and even grains can suffer. Leftovers stored in unventilated containers trap steam as they cool, leading to excess internal humidity. This condensation collects on lids and food surfaces, creating wet conditions that enable bacterial proliferation. Similarly, grains like rice and quinoa, when improperly cooled and refrigerated, can become breeding grounds for Bacillus cereus, a foodborne pathogen that survives cooking and multiplies in moist environments. This bacterium is responsible for many instances of reheated rice syndrome, leading to gastrointestinal distress. Another major issue is the presence of condensation inside food packaging. Vacuum-sealed or shrink-wrapped items, once opened, often become contaminated if exposed to damp air or are returned to cold storage without being properly re-wrapped. Cold meats, cheeses, and fermented products can quickly develop mold blooms or become hosts for listeria, especially in older refrigerators with inconsistent temperature regulation. Listeria is particularly dangerous for seniors, pregnant women, and those with compromised immune systems. Bread is a food that many people mistakenly refrigerate, thinking it will last longer. In reality, refrigeration often hastens mold development. The fridge's humid environment causes condensation to form inside the bag, promoting fungal growth. While freezing bread is effective, refrigerating it creates a damp, lukewarm condition that actually speeds up spoilage. This same principle applies to pastries, muffins, and other baked goods. Moisture is the enemy of shelf life in these cases. Condensation doesn't just affect individual foods, it can compromise the entire refrigerator environment. When water pools inside crisper drawers or under food containers, it can encourage the growth of microbial biofilms. These are slimy layers formed by colonies of bacteria, making them more resistant to cleaning and disinfecting agents. Once a biofilm takes hold, it can continuously contaminate surrounding food items, even if they're placed there later. This is why recurring food spoilage often points not just to the food itself, but to the storage environment's overall cleanliness and humidity levels. Mold, in particular, is a resilient invader. Once spores are released, they can settle onto other surfaces in the fridge or pantry, creating an ongoing contamination issue. Even when visible mold is removed, microscopic roots called hyphae may still be embedded within the food or container. Eating mold-contaminated food can trigger allergic reactions, respiratory issues, and digestive upset, especially in sensitive individuals. Many consumers rely on plastic wrap, Ziploc bags, or clamshell containers without realizing these traps can worsen condensation. When warm food is sealed without being properly cooled first, internal steam turns into trapped moisture. This wet environment quickly turns what could have been preserved leftovers into bacterial incubators. Using breathable storage methods like paper towels inside produce bags or loosely sealed containers can help absorb moisture and prevent microbial growth. Additionally, the cleanliness of the refrigerator plays a vital role in preventing mold and bacteria from spreading. Drip trays, gaskets, and shelving often collect invisible condensation over time, and if not cleaned regularly, they become reservoirs for microbial activity. Unchecked leaks or faulty temperature controls can also cause recurrent humidity spikes, making it impossible to prevent condensation even with the most careful food handling. For those trying to support their gut microbiome and reduce toxic load from spoiled foods, managing condensation and humidity must become a part of routine food care. Choosing proper containers, ensuring airflow, cooling foods before storage, and regularly cleaning the fridge are practical steps that help reduce mold and bacterial overgrowth triggered by moisture. Some foods must be kept cold to prevent toxin formation, as certain bacteria and molds thrive at room temperature and can release harmful compounds if left unchecked. While refrigeration is often thought of as a tool for preserving freshness and flavor, its most vital role is as a barrier against microbial contamination and the dangerous byproducts that can follow. The cold temperature in a refrigerator, ideally between 34 DEGF and 40 DEG, 1 DGC to 4 DGC, slows down or halts the growth of many pathogenic organisms. But when these foods are not stored properly, particularly those with high protein, moisture, or fat content, they can quickly become breeding grounds for toxins that may not be visible, smellable, or removable through cooking. Protein-rich foods such as meats, dairy products, and eggs are among the most critical items that must be kept cold. These foods are highly susceptible to bacterial contamination, particularly from organisms like Clostridium perfringens, Staphylococcus aureus, and Salmonella. When meat, for instance, is left at room temperature for even a few hours, these bacteria can multiply rapidly and begin producing toxins. In the case of Staphylococcus aureus, the toxin it releases is heat-resistant, meaning that even if the meat is later cooked thoroughly, the toxin itself may remain intact and cause food poisoning. Symptoms from these toxins can range from nausea and vomiting to more serious digestive disturbances. Eggs are another example. Though they may appear clean and safe on the outside, eggs can harbor Salmonella enteritidis, especially if left at room temperature for extended periods. Once the internal temperature of the egg rises, the bacteria can penetrate the shell and multiply within. This is why in many countries, refrigeration of eggs is mandatory from production through to sale. Similarly, dairy products such as milk, cheese, and yogurt must be kept cold because they are excellent nutrient sources not just for us, but for bacteria as well. Warm milk quickly becomes sour and potentially toxic due to microbial overgrowth, and soft cheeses can harbor Listeria monocytogenes, a particularly dangerous bacterium for pregnant women and the elderly. Seafood is another high-risk category that must be kept consistently cold to prevent toxin formation. Certain fish like mackerel, tuna, and mahi-mahi are prone to developing histamine poisoning if not stored at low temperatures immediately after being caught. This condition, known as scumbroid poisoning, occurs when naturally occurring bacteria convert histidine in the fish into histamine. Once formed, histamine is heat stable and cannot be destroyed by cooking. Reactions can include rash, headache, nausea, and even respiratory distress. The importance of keeping seafood cold from dock to dinner table cannot be overstated. Cooked foods also require refrigeration if not consumed immediately. Many people assume that once a food has been cooked, it's safe. However, cooked foods are especially vulnerable to bacterial contamination once they begin cooling. As the temperature drops from hot to room temperature, there's a window known as the danger zone between 40 DEGF and 140 DEGF, where bacteria multiply the fastest. If food is left out too long, especially in a covered container where steam and moisture are trapped, the warm, humid conditions become a perfect environment for bacterial toxins to develop. Now, even plant-based foods are not exempt from this principle. Cooked rice, lentils, and legumes must be refrigerated promptly because of the risk of Bacillus cereus contamination. This spore-forming bacterium can survive the cooking process and later become active when temperatures are favorable. It produces toxins that can lead to foodborne illness, particularly if the rice is reheated without being stored properly first. Similarly, pre-cut fruits and vegetables need cold storage because once the skin or rind is broken, the exposed flesh becomes an open invitation for microbial invasion, especially if moisture is present. Mayonnaise-based salads like coleslaw, egg salad, and potato salad are particularly risky when left out at room temperature. These mixtures often combine multiple high-risk ingredients, eggs, dairy, and moist vegetables, creating an ideal environment for bacterial growth and toxin formation if not chilled. This is why food safety guidelines recommend keeping such dishes on ice or refrigerated until serving. Fermented foods, while generally resistant to spoilage, also have refrigeration guidelines to ensure safety. Once fermentation is complete, the process must be slowed down to prevent over-fermentation and the accumulation of unwanted byproducts. Sauerkraut, kimchi, and kefir are examples where refrigeration not only preserves taste and texture, but also prevents the overproduction of certain acids or gases that may make the product unsafe over time. Another often overlooked category is leftovers. While it's easy to assume yesterday's meal is safe, improper cooling and delayed refrigeration are among the top causes of foodborne illness in the home. Leftovers should be cooled rapidly, ideally within 2 hours of cooking, and stored in shallow containers to allow faster temperature reduction. Storing large quantities in deep containers can result in the center remaining in the danger zone for too long, again, allowing bacteria to produce harmful toxins before the food fully cools. Even condiments and dressings, particularly those containing eggs, dairy, or fresh herbs, must be kept cold. Homemade or natural versions without preservatives can spoil rapidly if left on the counter. Bacterial toxins in such mixtures are subtle but potentially dangerous, especially when consumed repeatedly in small quantities over time. Improper food storage doesn't just lead to spoilage, it can have a significant and often overlooked impact on gut health, digestion, and even blood sugar regulation. The integrity of our digestive system depends heavily on the quality of the food we consume and how it's handled before it ever reaches our plates. When food is not stored properly, either exposed to fluctuating temperatures, oxygen, moisture, or light, it begins to degrade in both its nutrient value and microbial profile. This degradation directly affects the gut microbiome, compromises digestive efficiency, and triggers metabolic imbalances that interfere with blood sugar stability. The gut is a delicate ecosystem composed of trillions of bacteria that play essential roles in digesting food, producing vitamins, regulating inflammation, and influencing mood and immunity. These microbes are highly responsive to the quality and type of food we eat. When improperly stored foods are consumed, they may contain oxidized fats, denatured proteins, or altered fibers that irritate the intestinal lining and shift microbial populations toward a more inflammatory state. For example, when fats, especially polyunsaturated oils, are exposed to heat, light, or air for too long, they become rancid and form lipid peroxides. These compounds generate oxidative stress in the gut, damaging cells and disrupting microbial harmony. Another common consequence of poor food storage is bacterial contamination, even if the food doesn't smell off. Foods left at room temperature or not cooled quickly enough can foster the growth of harmful bacteria like Clostridium perfringens, Salmonella, or Escherichia coli. These bacteria, once ingested, don't just lead to temporary gastrointestinal distress, they also weaken the gut barrier, inflame the intestinal lining, and shift the balance of gut flora away from beneficial species. Over time, this chronic disruption can contribute to leaky gut syndrome, where food particles and toxins slip into the bloodstream and trigger immune responses. The issue extends to blood sugar balance as well. Foods that are improperly stored, particularly carbohydrates and starches, can undergo chemical changes that make them more glycemic. Cooked and cooled starches like rice or potatoes are known to form resistant starches which benefit blood sugar regulation and feed beneficial gut bacteria. But if these same foods are reheated multiple times, stored improperly, or kept at warm temperatures too long, they may lose this resistant property. The glycemic index increases, meaning the body will experience a faster blood sugar spike after consuming them. This instability in blood sugar contributes to insulin resistance over time, especially when combined with poor gut health and systemic inflammation. Fermented foods offer another example. These foods, like sauerkraut, kefir, kimchi, or yogurt, are rich in probiotics and enzymes that support digestion and gut balance. However, when they are stored incorrectly, such as being left at room temperature for too long after opening, the delicate microbial balance can shift. Harmful bacteria may outcompete the beneficial strains, or spoilage organisms may develop. Consuming spoiled fermented foods can lead to bloating, indigestion, and microbial imbalances that undo the very benefits these foods are supposed to provide. It's not enough to simply include fermented foods in your diet. They must be properly handled and refrigerated to preserve their therapeutic value. Another overlooked factor is how improper storage affects fiber-rich foods. Whole grains, nuts, seeds, and legumes contain natural oils that can oxidize when stored in warm or humid environments. Oxidized oils from these sources not only taste bitter and stale, but they also produce compounds that disturb the gut lining and increase inflammation. Furthermore, mold growth on improperly stored grains or nuts can introduce mycotoxins, chemical byproducts that are toxic to both gut microbes and liver cells. Even if the mold is not visible, the toxins may already be present and exerting harmful effects. Pre-cut fruits and vegetables also degrade rapidly if not kept cold and properly sealed. The act of cutting increases surface area, releasing enzymes that begin breaking down cellular walls and nutrients. This process, if combined with exposure to air and temperature fluctuation, reduces the antioxidant content and allows pathogenic bacteria to colonize. Eating these compromised foods can lead to gas, cramping, and irregular bowel habits, not because the produce was inherently bad, but because it was stored carelessly. Even beverages are not exempt from this problem. Juices and smoothies left unrefrigerated can ferment slightly and become breeding grounds for yeast or bacteria. Consuming such drinks may contribute to bloating and blood sugar spikes, especially if consumed in the morning when cortisol is high and blood sugar sensitivity is reduced. Additionally, milk alternatives like almond or oat milk can separate or spoil if not stored correctly, leading to digestive irritation or nutrient loss. Ultimately, food is information for your body. If the storage process distorts that information by introducing spoilage organisms, oxidizing nutrients, or degrading enzyme activity, then the messages being sent to your gut and metabolism are compromised. This results in poor digestion, microbial imbalance, and unpredictable blood sugar swings, even if you're eating what appears to be a healthy diet.